All right. Are you all set? That's good, you're all eating. Perfect. Well, I'm going to give a little talk about one of my favorite software architectural patterns, hexagonal architecture. Why? I've been using it for the past few years. And when VJ, who isn't here, approached me and said, well, can you talk about something about Go? I was like, yeah, sure. Let's do hexagonal architecture. Because the way I used to do hexagonal architecture sometimes conflicts with the core principles of Go. So that's interesting, but also because it's one of the patterns I found to be quite useful in almost any situation, because it's such a general and broad usable thing. Well, first about me, who am I? I'm that guy. Nice to meet you. You can find me over here, and after this presentation I'll probably upload the code also to that GitHub. Still working on that. If you have questions, you can email me over there. So, I'm Pim. I've been working with Go since 2016. I used to do a lot of C#, and then I went to a startup and I started working there, and we're like, no, Go is the way. And so I got there and I started doing Go, and I was like, okay, sounds fair, let's do that. That's a few years ago. Now I'm working at Energy Zero, one of the promoters of the meetup. I'm a tech lead there since recently. I'm from Utrecht, and recently I became a proud owner of a pet robot. So that's a little bit about my background. Right. Anyone here who's been working on software architecture recently? That's a few. Anyone working with Go? All right. How many of you do Go professionally? All right. And how much just out of hobby or interest? All right. Well, you're all at a great place because this applies to anyone. Anyone can use this. It's not really scary. And once you get to use it, it's a really simple way of building software. It makes your life easy. For those who might have heard of one of the names, it's called hexagonal architecture. People sometimes call it hub and spoke or ports and adapters. Anyone heard of this before? Good. Not everyone. All right. Let's start with a little game of Never Have I Ever. You might know it as a drinking game. Does anyone still have a beer? I don't think so. So let's do it with hands. Never have I ever had to set up other code to test a change. No one? All your code just is easy to test? Always?
Are we supposed to raise the hand?
Yeah, sorry. You're supposed to raise your hand if you ever had done this.
Okay, then, yeah,
Oh, that's a lot better. Perfect. Never have I ever dealt with a big ball of mud. Great, that's almost everyone. Our jobs are so fun, aren't they? Never have I ever had a single layer. All right, all right. For everyone who's wondering what's wrong with this, I have some example code I'll show you later, and I found out that building your example code like this really takes an age. If you think, well, but this works really well, if you're doing a really small project and you're not exposing it anywhere, be my guest. But doing this on a little bit of a larger scale might make your life terrible. And for all you professional programmers, never have I ever had a fragmented business domain. Have you ever had this problem where you're building code and you're thinking like, all right, I've got to fix this bug and it's probably very simple. I know about this process and you know, you've got like a refinement and you think, yeah, makes sense. And then you start diving into the code and you figure out that you're trying to retrieve some kind of object. And then it turns out, let's start at the top at the surface. Let's see if my pointer works. Oh my God, it's amazing. So let's say we've got a service and we do a use case, and apparently that's about some kind of group we want to do stuff on. And then the first step is getting that from your repository. And then we go to this magic repository and we're like, oh yeah, we're just getting the use of the group, right? And you dive into the code and like, oh wait, we're not getting all the use of the group. There's a special subselection that only applies to this use case. So that adds some mental complexity, right? You need to keep that in your brain while you're debugging and building your code. Well, let's go back. And then somewhere along there was this special bug and we figured out, well, let's do a quick fix. Let's just apply this little band-aid here. So if the user data, which I just modeled as a map because I'm very lazy at building example code, don't do this in production, please. We just had a talk about JSON. So this is something else that's interesting. And then finally we go to our actual user object. And then here also there's a lot of business logic happening. Right. So why is this difficult? Clearly you've got 3 separate places where apparently very specific business logic is happening. If you've got this in your code, this is your talk to listen to. So, hexagonal architecture in a nutshell is about separation of concerns, which means that each part of your code only does like one important main thing. It doesn't mean your code does one really small thing. It has one concern. A clean core, and by a core I mean the code you actually really care about, the code that models your business process, the stuff you actually want to automate. And finally, it's flexible. So for instance, you're working with a JSON API, you're feeling like switching it up. This should make it really easy because you can easily switch just one part and have gRPC. And finally, it's simple. That doesn't mean, by definition, it's easy, but once you get a hang of it, it will make your life a lot easier because the thing itself is simple. So, let's first start with a bit of an abstract view of hexagonal architecture. In the core, it's about 3 layers that help you define the parts and the responsibilities of your application that you really care about. So the first layer, we've got these adapters. To compare this to an analogy, let's say you've got a company, and at this company, you're working all over the world. Then your first layer will be the people talking to the other companies and the outside world. And that may be in any language. It could be English, Dutch, German, Japanese, I don't care. And that's all happening in this outer layer. This is the part that interacts with external systems. On the left side, a request might come in, like this. So we've got our REST HTTP server running, getting all these nice requests, or we're listening to events. And on the other side, we might also want to interact with the outside world. So we might want to store stuff in a database, or interact with another service or a client. That's the first layer. It's that thing that helps you connect your application to everything else. Then in the second layer, we've got our ports and services. So this is where our functional requirements start. And this is kind of the management layer, middle management. It kind of ties everything together, checks with everything, but it doesn't really do the business value. And this is a layer where you find your interfaces in Go. So for those of you who aren't that experienced with Go, it's a good practice in Go to define your interface at a place where you consume something and not at a place where you've defined the implementation, which may be different to other languages. So here you've got your services. And something I'll hit later on, dependency injection. Now, this layer is probably a layer where you'll get something from a repository, you'll start some kind of process, and usually this is where you should talk with your entities and make them do stuff. And then in the core, we've got our business logic. So here we've got our entities. So in the example of the user, this is where you would actually make the user do stuff and get the result. This works really well with domain-driven design. And this is the core. Sometimes they will say this is also part of the core. That depends on how you design it. That's up to you. So we've got our 3 layers. And the very important thing is they all do different things. Is that clear so far? All right. So,
I have one question.
Yeah.
On the previous slide, in the port and services, if you go there. Yeah, protocols, you mentioned it as the first word below. I would expect it to be in the front, right, where you have incoming requests?
Oh yeah, the protocols, yeah. No, I've grayed this out and I apparently didn't change the text. But yeah, the protocols and the stuff lives here. Right. And it's grayed out and it shouldn't have been there. This is an old slide. Okay. My bad. Thank you for asking. So, we've got our hexagonal architecture. And there's one very important thing about this architecture. Why does it work well and why should we do it? Well, there's this rule in hexagonal architecture that you can only go from the outside in. So the outer layer knows about the inner layer, but the inner layer doesn't know about the outer layers. So what you might seen in your happy big ball of mud is you've got this code and somewhere deep down the line you're doing something and then, surprise, here's a new repository, or you're instantly talking to a new service and you couldn't see it on the outside. That's something we really want to prevent. So the idea is that in your core logic, you have no real dependencies on other stuff. So that's where the second layer comes in, the ports and the services. They get to manage that. So when you're testing your code or you're making a unit test, it should be really simple to test your business logic without having to deal with a lot of other stuff. All right, then a little sidetrack. Because if, as you said, in these layers we cannot go out, how can we make our manager, like the second layer, our services, talk to our repositories and actually do requests to other clients? So there's a little hack called dependency injection. How many of you know it? All right, that's almost all, but not everyone, so that's good. Dependency injection is really about saying, all right, I've got a service and it needs to talk to something, it needs to do something, but it doesn't know how to. Make sense? I see some nodding faces. So let's go over this example. We've got our cool service, which I aptly named, and it needs to get stuff, apparently by its string name. Now, it doesn't know how to do it, it just knows that there are people out there that know how to do it. So it'll just define at the service level, I need this thing that does stuff for me, and then somewhere else in the code, like in this repository, we know how to get stuff. So the service just says, I need something, and somewhere else will say, here's the thing that does it. And this method matches this signature. So here you'll see me defining an interface at the place I'm using it. The server consumes this. And then, to tie it all together, we're starting up our code somewhere in the main.go, and here we wire it together, and this is why it's called dependency injection. Oh, no, that's going one slide forward. This is a dependency of this thing, and we're injecting it into the thing. So this is dependency, and we're injecting it here. And our service doesn't need to know how to do stuff. So if we say we've got a Postgres repository, you can now easily swap it out for something else. Could even be a client to some other service. All right, trade-offs. Before we go into the code, why should you do it, and what's the trade-off? Well, the pros, you've got a clear basic project structure. It doesn't solve all your problems, but it gives a really good start. Testing is a lot easier, as you saw in the first kind of code, where you're doing everything in one place. You need to test everything from the first to the last layer. It's really difficult. Well, it takes a lot of time. And right now we can test each layer independently. Maintainability, because we've decided to separate layers of concerns and separate parts of our logic, it's also a lot easier to maintain. As a developer, I don't need to know everything about every layer. If, for instance, I'm just working on the business domain, I don't need to know how we're serializing stuff. I don't have to care about that. So I don't need to know the entire application to build stuff. It promotes domain-driven design, so if you're into that, this helps a lot. And we've got a clear separation of concerns. The outer layer knows about the handshakes and the talking to other stuff, and the inner layer only knows the business domain. On the other hand, it does have a little learning curve. You need to get a feel and the hang of it and understand where do we place each part of the code. At first, it can feel a bit different than what you may be used to. And if you're doing it wrong, it can lead to a lot of boilerplating. So if you're doing a lot of boilerplating without adding value, you probably shouldn't be doing this. And it's last, the cargo cult and the boilerplating. If you keep doing stuff and you don't know why you're doing it, you shouldn't. Also counts for this principle. All right, let's dive into some code and see some examples. So now I'm going to hope that everything is ready. Can you see this? No, you cannot. Can you see it now? Good. Can I see my mouse? Yes. All right. So let's go over some example code from our horrible big ball of mud. So for this example, we've got a very simple web server, and it's got 3 endpoints. We've got a little recipe service. We've got some ingredients, and with those ingredients, we can build a recipe, and we can store the recipe, and later on retrieve it. Not that exciting. So we can get our ingredients, we can get our recipes, and you can post them. Well, let's see if you. Oh, yes. We can get our recipes. That's nice. Nice JSON. Everyone happy here. And our ingredients, we've got a huge list of ingredients to work with today. We're probably going to bake some cookies. Right, so this looks pretty normal, but then you see we've got everything nicely tucked away in one single package, no kind of ordering. So let's see what it takes to get an ingredient. Well, this is where it gets scary. We're listing our ingredients, and oh, there's some database code, but I don't know how to program with a database. And we've got to encode stuff, and we're doing all kinds of stuff I really don't know about. And that's just the simple part, we're just listing things. But let's move on and let's say we want to show a recipe. Well, that's a bit longer. It fills the entire screen. So we're getting our recipes. Then we need to marshal them here. And then we need to get for each recipe the ingredients because we only store the IDs in the database. And then we're doing all this custom code. And at the end, we're returning the value. And now there isn't really any business code in here, and it's already taking my entire screen. So this is a lot to take in if I'm starting at a new project. Obviously, this is a bit simplified, but you might get the feeling. There's a lot going on, and you don't really know why it is all in the same place. Now, if you want to create a recipe, it's getting even worse. So now, at this level, let's use a pointer. First of all, we're just trying to decode a request and understand what's going on. And now, oh, there's some business logic. Apparently, you can only create a recipe if it's got a name. That sounds maybe quite reasonable. But also, we need to check it has at least one ingredient, because a recipe without one ingredient, what are we doing? And then we're going to store that, and there's some extra logic, and there may come some errors, and then finally, if everything goes right, we return some answer like, hey, this worked. Well, that's a lot of work. There's a lot of mental cognitive overhead you're probably all feeling right now. If not, good on you, you're doing great. But I don't like this kind of code. It's quite distracting. So let's close it all out. And let's move on to something hopefully a little bit simpler. Example 2. So first, I set this up a little bit of a mono repo. So all my services are in one place. So I've got my other service, which does other stuff. We've got share packages, and let's go over this for a second. Can I increase my font size? No.
Yeah, you have personalization mode. Maybe you can do that.
No, okay, I'll skip that. Computer says no. Oh no, it's even worse. All right, so we've got a recipe domain. Can you read the folders over there? Also in the back? Ah, well, good. What's nice about this? Well, first of all, you might not like this if you're a hardcore Go programmer. There are a little bit more folders than you used to. I'm aware of that. But at least we've got a clear structure. And whenever someone new joins a project, we'll do the same everywhere else. You might also opt to, because this is my opinionated version, to just move everything one layer down. Important part, everything here is in the internal folder. On the inbound, we've got our HTTP server, which knows how to handle HTTP requests and do stuff with them. In the outbound, we've got our, in this case, SQLite repositories. So we've got one to store ingredients and one to store recipes. So this is all simple. These are our adapters. This is what's talking to the outside world. As soon as you start a project and you're not working this, you can just ignore that. That's nice. Then, secondly, we've got our core. So here's the service, and here are my entities. Well, let's start at handling a request. So let's say we start in our handler, and we want to say, well, I want to get all the ingredients. So we're getting the ingredients. Well, that's nice. That's really short. We're just simply saying, hey, give me that stuff. And now all I'm doing is translating it into my presentation object and returning it. Life's easy. I can understand it. It's what, 10 lines of code? Does it feel better? Does everyone know what's happening here? Well, that's good. So how did we do that? Well, simple. We defined this interface that says, well, if I want to handle this endpoint, I want to do this, this is what I'm going to need. So this one lists my recipes and it gives me all the ingredients. Well, then how do I do that? Well, let's go to the service. And here in my service, I've got this endpoint and it says all ingredients. Well, this is kind of a pass-through method. If this is all your application does, don't do hexagonal. We'll move on to a more clear example of when you should do it. So, again, my service simply says, hey man, I need a repository that returns me information. I don't know where you're getting it from, I don't know where you're storing it, but this is how I want to get it. And then down the line, at my outbound, I can implement this and make sure it works. So let's go there. Well, here we're listing our ingredients. And now you can see you can also, this is a nice hack if you don't know it yet, enforce interface implementation simply by doing this. Well, now we know how to get ingredients. Let's move on to the more advanced example where you might want to use it. Let's create a recipe. We can guess the HTTP endpoint by now. But this is where you see Hexagonal doing its work. First of all, we're getting our ingredients, because apparently someone said, hey man, I want to create this recipe, and these are the ingredients I want to use. So they've previously got the ingredients, and now they're getting them. Then we can create a recipe, and still we don't see any business logic in place, right? But now we can go in here, and this is where we solve our core domain. So this is where we got all our rules. So for instance, in this case, they're quite simple. We say, well, it needs to have a name between 5 and 100 characters, and we need to have at least one ingredient. So all of the stuff we demoed in the really large part of code is now easily contained. I don't need to think about everything of the rest of the application to do this. Same for adding an ingredient. We can just simply add a line here that says, hey, you can do that. And here, we're removing an ingredient, and you can say, hey, well, it's not allowed if we do it like this. So, oh no, that's not good. Let's see if it comes back up. It should be, okay. How long will this take? Until now. All right. You can do it.
Can I ask a question meanwhile?
Yeah, sure.
So your story is somewhat similar to mine. I started in 2016 as well and have been doing some Java before.
Yeah.
So it's similar to .NET. And I have been using hexagonal architecture. And sometimes deep at night at about 3 a.m. I open Rob Pike's GitHub and I go to Upspin, one of the bigger services that he wrote, and I see very procedural code, like from example 1, where you have deserialization, you have database queries all in the same function, very straightforward. And I start questioning myself, am I bringing this from my Java experience into Go? Like, when I will do this full circle and return to a very procedural approach? Have you been asking yourself this question?
Yeah, sure. So the question is, have I asked myself, should I really do this, or should I keep going back to procedural code, right?
Maybe do you find place for more straightforward in bigger applications?
Depends. The last few years I've been working at several startups, and we had a lot of switches of code and doing different implementations. And at that point I found this working really well for me. So unless you're really sure your stack isn't going to change, then sure, you can do it another way. But I've also noticed that, especially when working with junior engineers, this is a lot simpler, because you don't have to understand the entire stack. So depends on the team you're working with and how well everyone knows the tools. I guess it's all to do the architects, but personally I prefer this way because it's easier for everyone to comprehend. And I know it kind of violates a few of the Go principles, but I have to accept that.
Yeah, I understand.
So yeah, where was I? Yeah. So the business rules are now all contained in this one layer. That makes my life easy. My service only handles the other stuff, so also I could increment some metrics here, could also do somewhere else. Sending events to somewhere else, that can all happen here, because my core logic doesn't need to know who needs to be notified. And then finally we can store it. Also a nice thing of doing it this way is you can have your commands here and do other stuff. So here we've got our main and our setup. But also we could add some cron and it can use our internal services without exposing to the outside world. And for instance, you can still have your package here and have some default client. Usually you could generate it and we can import it somewhere else, like here. Let's see, where was I? Right. So that was hexagonal architecture in a nutshell. I think this one isn't working. This one is. Questions in the back?
Yeah, what if you have very long run processes that you've created that are both client and server at the same time? Like if I, for example, do a telephony call to you, and you call somebody else, and then you transfer me, and then I call somebody else and I transfer him. We're doing this constant bidirectional thing, because you have this adapter inbound, outbound, but what about stuff that is inherently bidirectional and changing all the time? And does that still fit this structure in some way?
If you have bidirectional communication, I guess, well, switch it up. Then maybe just put it in one adapter layer.
And if it starts really running a lot of long-running processes, like I have to at some point do an outbound call, for example, right? I just have to depend on something outside. Like
Yeah.
It's very doesn't it like totally violate this principle?
Why would it? I mean, you could just say, well, we only got adapters and not differentiate between in and outbound. That's fine. But it's smart to keep it all in that one layer then, yeah. Yeah.
Yeah, sorry, I didn't get it from the code, but what do you think about separating the domain model from the data model?
Oh, yeah, that's a good one. That's something I forgot to show, actually. I'd say really, really separate that. So here in our adapter, where to put one? Yeah, so I've got my model and this is unexported. So only my adapter knows about dealing with that stuff. I really do not recommend using one model everywhere. I mean, when you're starting out, it feels like I've got a lot of speed. I only have one model, it's all the same, right? And then for some reason you need to store something extra in the database and you forget about it and it's now also in every part of the application. And then somewhere along someone else says, hey, that's nice, I'm going to use that. And then eventually you'll still return to the big ball of mud, but now you've got just a single model. So please don't.
Yeah, I can see also here you transform the data to a domain inside the data model.
Yeah.
Right? It's not the other way around.
No, so
I
the...
just question myself, should I transform it from the data or from the domain model? Which one should I...
Yeah, so the repository receives a domain model. And then you're transferring that to whatever you're projecting onto your database.
So inside the repository?
Yeah, definitely. So my service layer doesn't know about the backing storage. All right? Anyone else? Yeah.
Why is it called hexagonal? What's the 6 in that?
Oh, yeah.
I kind of missed that.
Yeah, that's a very good point.
Yeah, I wasn't paying attention.
I think I missed that. So the idea is that you've got, oh, that's a long time ago. An hexagon, and each part, well, it's clearly a layer. It's also called an onion architecture. But the thing is that you've got stuff going in on each side. And so in this hexagon, the left side is like the inbound, and it's got different routes of getting stuff into the system, and on the other side is outbound. And that's why they decided to call it the hexagonal.
So this is the difference between onion and hexagonal?
I think it's the same, but I'm not quite sure.
It is the same.
Yeah, it's the same. It's all about the layers. Thanks. Yeah?
A question. Frequently, inexperienced people will try to create anemic business logic in the very center. And what I mean anemic is that you have entities which almost exclusively contain getters and setters.
Yeah.
Question. Well, do you have experience seeing this in the field? And
Yeah.
The second question leading to that, well, how do you typically sell the benefits of defining the business logic in a proper way?
All right. So if I summarize why do this and not have just a lot of getters and setters.
Yeah. Yeah.
Well, I've seen a lot of code also in Go where you just got a struct and then you don't even need the getters and setters. And then the service would do everything. And then the difficult part is you lose track of which service does what and what is allowed. So by doing this in this way and allowing the methods only on the entities, we can really enforce that each action, which can be called from anywhere, is done in exactly the same way and we don't forget about stuff. Because what usually happens is that's some place you say, well, we've got this process in place here, and then later on we need a minor tweak and we kind of replicate it and then forgot about a check or forget about something else. And by doing it on the model itself, you can really enforce how it's being used. You can also hide certain information by making it unexported to ensure that outside it cannot be used. And then what you can then do is just either change your state or return a new state. That depends on how you're using it and what your needs are. but mostly just making sure that all the logic stays in the same layer. Right?
Can I ask one more question,
Yeah.
please? What if your business logic has to be thread safe? How would you program it?
If it needs to be thread safe?
Yeah.
I don't see.
To give you a hint, for example, Java and Scala would do, they would introduce the concept of immutability.
Yeah.
So you have a business logic, and the business logic works on immutable objects. So the moment you change something, you create a new copy, and you ditch the previous one.
Yeah.
So I was wondering, what is your experience doing this business logic programming in Golang intended for high concurrency use?
Well, what I'm not really sure it satisfies your answer. Maybe
Okay.
I'm not too experienced with that. But mainly I would make sure you just load all the objects within your request once and don't share them across other stuff. Yeah, it's not really.
Okay, thank you.
I can add one thing to this question.
Yeah.
I'm coming from Django framework, and they always promote the fat model. And I see always a problem that they fit the business logic inside the data model. And after like 1 year of adding business logic to data model, it's one of the hell to take it out and make a domain model. It's like developer velocity will go down, and they will not understand what is the business logic. Like this is data or business or whatever. So this is one of the negative side of fat model architecture or design. We hate it.
Okay.
I hate it. Like I don't like it. That's why I like this.
All right. So you're storing all the stuff in the data model and you share it everywhere, or?
Yes.
Ooh.
In Django, there is a data model, and you can keep adding business logic to it. Validations.
Oh wow.
Like, yeah. And so on.
Well,
It's
glad
good
you're doing
to
Go
start
now.
with, but afterward, like, it's a hell to second.
Well, thanks for sharing. Yeah.
So I've worked with this, and then one of the things I ran into was when you need to have something that lives on sort of both sides of the outer layer. Like for example, you want to do cross-service request tracking, and you want to carry some sort of tracker from one side of the incoming request
Yeah.
to all the outbound requests. Then I found myself sort of in a situation where the only solution that I could think of was stuffing it in context
Yeah.
to make sure that I can pass context all the way down.
Yeah.
And then everything is sort of supposed to be able to return an error, because when that context is inevitably possibly missing at the other end, I sort of need to lift that error all the way up. So is there a better way to deal with that, or
No.
no? Okay.
No. If you've got stuff you need to carry over, yeah, you got to put in the context.
That's it.
Oh, we're out of time. Thank you so much. Thank you very much.